it too, it just wouldn't be nice. Alright, so let's talk about 1-1. Very important little section. With a lot of little pieces in it, and that's the danger of it. The other danger is this. You already know how to do some of this, but you can't think, oh, I already know how to do this, so I don't need to learn it. Because there's some little details that none of your teachers have ever taught you before. So I have to kind of go through the entire process of how you do this, no matter what kind of linear equation you're dealing with. The linear equations you're used to are simplistic. They really are. So I'm going to make them worse. So steps to solve linear equations. There are 6 of them. See, a lot of the time, if I ask you how do you solve a linear equation, most of you would say get the variable by itself. That happens to be step number 6. There are 5 other steps above it that you have to go through to get things to be x by itself. Step number 1, sometimes helpful, sometimes not. Remove fractions. There is a neat little technique if you're dealing with an equation where you never ever have to deal with fractions, ever, which is kind of nice. The quotation means you're not just going to erase them, we're going to do some kind of process to get rid of them. 2, I think I spelled that right.
Yes.
I hate that word.
Your E.
Where? E-R-N. I just hate that word. Again, we're going to remove the parentheses, but this one is by a property. What property? Distributive property. 3. All right. Oh, by the way, anytime you remove parentheses with the distributive property, your next step is automatically simplify. Combine like terms, bring things together, make it look a little bit nicer. All right. Step number 3, move that's wordy, but it gets a point across. Move by the additive inverse. In other words, if it's a positive 2x, you'll subtract 2x. If it's a negative 2x, you will add 2x. What's the additive inverse do?
What?
When you use an additive inverse, what happens?
Cancel.
And they become, well, that's multiplicative inverse. Additive inverse. 0. And 0 is the additive identity, which doesn't change anything. So when we say cancel, we're doing an inverse and a identity. All right, so we're going to move by the additive inverse, not by division, not by any other weird thing, just additive inverse. The variable you're trying to solve for to one side. Now, in an equation, there's a left side and a right side. I'm not telling you to move it all to the left or all to the right. Just move it one way or the other. Step number 4, move anything else to opposite side. So if you move everything, all your variables to the left, move all your junk to the right, you move all your variables to the right, move all your junk to the left. Makes sense. 5, isolate the variable. Sometimes it's already isolated at this point. Sometimes it's all pretty much by itself. And then 6, usually use multiplicative inverse to solve. Not all the time, but for the most part, you'll use the multiplicative inverse. Now, some of these steps, they're not going to happen all the time. Like, some equations will not have fractions. Some equations will not have parentheses. Some equations, the variable is already on one side by itself. Some equations, once you get the variable on one side, all the other junk is already on the other side. So you can skip some of these if they're not appropriate. Now, I'm going to put one up here and just, kind of run through it. Simple equation. Probably before this class, you should be able to solve this equation fairly quickly. And you wouldn't have to necessarily go step by step. The reason for my step by step is when you get stuck. When you look at an equation, you have no clue what to do because it'll look slightly different than this one. That's when the steps come in handy. But they do work pretty much here too. No fractions, so we don't have to worry about step one. There are parentheses, so I need to distribute. So this 5 minus 3 becomes 2, right?
No.
No.
Please don't do that. Distribution has to happen first, so negative 3 times this and negative 3 times that. So 5 minus 3x minus 6 plus 4 is equal to 7 plus 8 minus 2x. And like I said, you should be able to do this before I even get done. After you get rid of the parentheses, your next step really should be to simplify. On the left, it's just numbers that are simplifying. So 5 minus 6 is negative 1 plus 4 is 3. So we'll get 3 minus 3x. Or negative 3x plus 3. I could care less which way you write it. This side is 15 minus 2x. All right. So that would be step number 2. Remove the parentheses and then simplify. All right, the next step is get your variables on one side. Do not look at the 3 or the 15. They're irrelevant. Those are the junk. You want to keep your focus on the variable you're solving for. So you either move the 3 or the 2x. Which one do you want to move?
I do the negative 3.
Most people would move the negative 3, but there are some people that like moving things to the left. Okay. So if you're going to move the negative 3x, it has to be by the additive inverse. So negative 3x additive inverse is positive 3x. And then another property takes over that I've never written down, but this is it. It's called the additive property of equality. If you add something to the left, you just have to add something to the right. So since I added 3x here, I just have to move it and add it over on the other side. Make sure that you're doing this on the left side of the equation and the right side. I have seen people do it both on the left. They see a 2x and a 5x and they, subtract the 2x, but they're on the same side to begin with. Hopefully, this step here takes care of that, combine like terms and all that. So on this side, what happens?
They cancel.
They cancel, which is inverse identity, and you're left with 3. Try to keep your equal sign straight down. The reason for that is so you don't lose it. I've seen people lose it, shift everything to the left, and then all of a sudden they move an equal sign someplace. So just try to keep it straight down. On the right-hand side, 15 plus x. And here, you can see that x is pretty much, it's isolated. It's one instance of x. That doesn't always happen. All right, now the next step is get the junk to the other side. So your focus is on x. The 15 is in the way, so we're going to additive inverse it away. And finally, we get down to negative 12, and x is equal to it. I like putting x first. It is a good habit to get into, especially when we start dealing with inequalities. So there's a property that actually allows you to flip over an equal sign. It's called the reflexive property. If A is equal to B, then B is equal to A. Or is it A equals A? Symmetric. Symmetric property.
To the left.
Symmetric property. What's that?
I'm moving something in the beginning. You like moving your stuff to the left.
Yeah, you can. I mean, there's no reason why you couldn't add 2x to both sides. The thing that you also could do is you could divide by like if this was a positive 3 and you subtracted it over and you had negative 5, your next step could be divide by negative 5, but then it creates possible fractions, and that's just, it's not wrong, it's just, you can do it, I just wouldn't suggest it. All right, so most of you can do that, right? Mm-hmm. Okay. When I was in school learning algebra, I had a worksheet that looked like this. There was 25 problems on that. And the teacher's like, all right, go ahead and do it. And they gave us a half hour to do it. By the third one, I got bored because you do exactly the same thing. Subtract 3x, add, subtract 1, and you go through the same process. So I got so bored, I went off to the side and solved this one instead. My teacher hated me. It took me 5 minutes to finish the worksheet. Why? Because if I solve that, I've solved all of them. It becomes a nice little formula. So how do I solve this equation?
Subtract
C.
B.
Subtract b? No, what
Subtract the C.
process over here says subtract b first.
Subtract C, C.
What is your focus supposed to be on? Well, the variable. The variable is x.
So,
So I either move the a x or the c x. Which one do you want to move?
subtract C.
Cx, all right. So we subtract cx from both sides. This is where the steps come in handy because things are a little weird right now.
Then you have AX minus CX.
Now you have ACX.
No, I don't have no acx. I have ax minus cx plus b is equal to d.
And then subtract the.
That's what I have. You can't just go and shove them together. You have to have a property behind it. Now, the next step says get all the junk on the other side. Well, what's the junk here?
Subtract B.
The b. So I'm going to subtract b from both sides.
So then you have AX minus CX equals D minus B.
I'm going to have ax minus cx equals d minus b. Awesome. Now, this is where step number 5 comes in. Isolate the variable. Right now, I have 2 instances of x. I need 1.
So then you divide by X.
If you divide by x, there's a problem with that. What if x is equal to 0?
When you
So would
factor
you-
out the X.
You'd factor out the x. You use the distributive property. So if you use the distributive property, you kick out the x. Here's a golden rule for you. Never ever divide by the variable you're trying to solve for, because that variable could be equal to 0, and then you're causing yourself a world of hurt. All right, what's left behind after I kick out the x?
A
A
minus
minus
C.
C.
A minus c. Okay. And then finally, how do I solve for x? Well, I use the multiplicative inverse of a minus c, which is
A.
divide both sides by
A minus C.
a minus c. And I finally got my x by itself. So I came up with this neat little thing, d minus b over a minus c. And I would go back to these problems over here and go, well, a is 3, b is negative 5, c is 7, and d is positive 1. And I would go, x is equal to d minus b over a minus c. And I would have my answer as 6 over negative 4, better known as negative 3/2, and I was done. And I did that for 23 problems. And my teacher was like livid. I always found shortcuts that they didn't want me to find. But what do we call this thing?
It's a formula.
It's a formula. That's all it is. It's a formula to solve this specific type of question. You know formulas, you know, like quadratic formula, which we'll be eventually getting to again. So this is the process on how to solve an equation. Let's throw one up
When
there.
did you figure that out?
What's that?
When did you come up with this?
8th grade. Yeah, they didn't like me in math class. I fell asleep most of the time. Let's see here. How about one with fractions? 4 minus 3x minus 2, all divided by 3, is equal to x over 6 plus 2x plus 1, all over 2. Ah, shoot. Forgot to clear my screen. Let me write it over again. Here.
This won't be the same one.
Yeah, same one. I just didn't clear my screen over there. 4 minus 3x minus 2 all over 3. X over 6 plus 2x plus 1 over 2. Alright. This problem, for some reason, causes people some headache. And the reason I think it causes headache is they forget what these long fraction bars mean. What do they mean?
Group.
Grouping, parentheses. There's invisible parentheses there. So probably one of the better things to do with this problem is just put them in. There's parentheses here and there's parentheses here. That means anytime you have to do something with that green grouping, you're going to have to distribute. The other problem is when you put a 2 and a 3 in those positions, is it affecting the first number or both of them? Both of them. By which property? There's parentheses and a number outside of it, distributive property. But a lot of people don't see this distributive because the number's sitting on the bottom rather than sitting out front where it's normal. So another way of writing this, what does it mean to divide by 3? How do I multiply to get the same result?
Inverse.
Multiply by? Well, sure, which is?
1/3.
1/3. So dividing by 3 is the same thing as multiplying by 1/3. So I'm going to write this thing as multiplication rather than division. You don't have to do it this way, but it is legal. You're dividing by a number, you're also multiplying by its reciprocal.
You could.
You don't believe me?
No,
Oh.
I'm
You could multiply everything by 6.
We're getting there.
Oh.
I'm just trying to get rid of some mistakes. I know that it will happen.
So if I was doing it without doing it that way, could you just working off the top problem would be like 4 minus the 3's cancel, x minus 2/3 now?
You could separate it all out, yeah.
Okay, so you can do it.
You can. I wouldn't suggest
That's
it.
how I started. Okay.
I wouldn't suggest it because then you're creating fractions, and people,
Okay.
for some reason, when they see fractions, have a conniption fit. So I'm trying to
I just want to
avoid
make
the
sure that.
fear. You could.
Okay.
Like I said, just like solving equations, you could do a lot of things first. It's just certain things are nicer.
Okay.
Like with
This property is nice.
exponents. If you do certain patterns with exponents, it usually works out nicer rather than get messy first. But this step is what I consider the mental step. Something you could do in your head.
Show me how you got the 1/6x.
Well, this is x divided by 6, which is the same thing as 1/6 times x. It's a neat little trick to be able to see what it is as multiplication rather than as division. Let me give you a simplistic example. Actually, I've already done this example before when we were dealing with rational exponents.
But if you multiply both of those by the reciprocal, why didn't you do the 1/6x by the reciprocal?
What's the reciprocal of 6?
1/6.
1/6. How do you divide a fraction by a fraction? You flip and multiply. Little things. Like when we were dealing with rational exponents, I said, well, you can separate 2/3 as a product. How do you separate it as a product? 2 over 1 and 1 over 3. Which is the same thing as 1/3 times 2. I don't know why people don't see things like that, but you know, they see it as a fraction. I see it as a product. Yeah. Just a different way of looking at it. Now, why do I want to see it as a product rather than as a quotient? Because a lot of people don't like mixing operations. Multiplication and division at the same time become kind of weird. The other thing is this. If you have 3 numbers multiplied together, how do you multiply them together? No. How do you multiply 3 numbers together? Like this was
First
2 times 3 times 4.
6 times 4.
You get the first 2, you multiply them together, you get
6.
6, and then you take that answer and you multiply by the last number. I have seen people go 2 times 3, 2 times 4, and take 6 and 8 and multiply them together, which makes absolutely no sense. But they'll do it over here. They'll multiply the 1/3 by the number, and then they'll turn around and multiply the 3x minus 2 by the same number, which makes no sense because that's not how you multiply numbers together. You associate, get an answer, and go on your merry way. All right, so that's another reason that I write it out this way, just to make it a lot clearer that when I do this neat little trick, exactly what I'm doing. The trick I'm going to use is, what's the common denominator between all these fractions? 6. So I'm going to take the entire left-hand side and the entire right-hand side and multiply by the common denominator. Totally legal because it's the multiplicative property of equality. Multiplication property of equality. If you multiply something on the left-hand side, just make sure you do the same thing on the right. Now, what do I have to do with this 6? Distribute it. 6 times 4?
24,
24. Then I have this 6 times a third, which is 2.
Oh.
Well, I have the minus sign down. And then this 3x minus 2 is there. What do I do with it?
distribute.
Nothing. Leave it alone. 2 times 3 is 6. You know, just write it down and see what happens. So 6 times a third is 2 times 3x minus 2 is equal to 6 times 1/6x is x plus 1/2 times 6.
3.
It's 3 times 2x plus 1. Just leave it alone. Too many people want to do 2 steps at once. And guess what happens when you do 2 steps at once? You screw up horribly. Now, we're down to no fractions, and we can go to our rest of our process. Get rid of
The parentheses.
the parentheses. So this is 24 minus 6x plus 4 equals x plus 6x plus 3. Yay! And things are kind of nice without fractions. All right, after you get rid of parentheses, combine like terms. 28 minus 6x equals 7x plus 3. Yay. No, you do not.
Add the 6 and subtract the 7.
Either deal with the 6 or deal with the 7x. Don't worry about the numbers, worry about the variable you're trying to solve for.
Add,
So either add the 6x or subtract the 7x, I could care less.
add the 6x.
Now, if you add the 6x, you're going to get 28 equals,
13x
make sure you change the sign when you move it over, 13x
plus 3.
plus 3. And then
Subtract 3 from both sides.
subtract 3 from both sides, so that makes this
25.
25 is equal to
13x
13x.
divided 13.
And I always show this step. No matter what happens, I will show the division at the end. There's a reason, and I'll show you in a second. And you get x equals 25 13. Yay! You want to check the answer? Neither do I, because that would be horrid. But it's possible. You could throw it in and see what happens.
Did you come up with this problem?
What's that?
Did you come up with that problem?
Oh, of course. Y equals 2x plus 3 over 4 minus x. Next chapter, we'll be doing a problem like this, and you'll all forget how to do it, which is fine. Whenever you're solving a linear equation, the steps never change. Step number 1, get rid of fractions. Step number 2, get rid of parentheses. Step number 3, get the variables on one side. Step 4, get the junk on the other side. Nothing changes. So what should I do first? Oh, by the way, I'm solving for x. Solve for x.
So you multiply everything by 4 minus that.
You multiply both sides by 4 minus x. So the left-hand side becomes,
4 minus x.
well, y times 4 minus x or 4 minus x times y. I could care less which way, but I like single. And then on this side,
It is 2x plus 3.
just the 2x plus 3, because
Cancel before.
these are going to cancel, which is rather nice. Multiplicative inverse, identity. All right, now what? Distribute, get rid of the parentheses. So this becomes 4y minus xy is equal to 2x
Plus 3.
plus 3. Okay, I already distributed.
Well, no.
Combine like terms.
Yeah.
There's nothing to combine.
Can't you do the y?
If I factor out a y, all I'm doing is going back up here. No point in that. Here's the focus. You forgot your focus already.
Solving for x.
You're solving for x. I can care less about y. Y is junk.
Do you subtract 3?
You gotta get the x, y, and the 2x together.
I need the x, y, and the 2x together. Your focus should be on the variables. One's on the left and the other one's on the
Right.
right. Where do they need to be?
Add it.
Same side. So either add x, y, or subtract 2x. Which one?
Add it.
Add x, y. I'll show this stuff. I'm going to add x, y here and add x, y here. Get the x's on the same side. That's your focus. So left-hand side, what's left?
4y
4y is equal to 2x plus xy plus 3. Nothing wrong with that. Again, your focus should go back to those x's.
Subtract the 3.
Get rid of the 3.
I mean the 3.
The 3. I just want to make sure. So subtract 3 from both sides. I'll show it just for the fun of it. Can you combine 4y minus 3?
No.
Please don't. I've seen people do it. So this is 4y minus 3 is equal to 2x plus xy.
Distribute out of X.
Distribute out an x or factor it out. It becomes,
4y minus 3,
well, 4y minus 3 is equal to
2x.
2 plus y. I'm kicking out the x. I'm not invited to the party anymore. And then divide both sides by
2 plus 1.
2 plus y. Now I'm just going to write the final answer. X is going to be by itself. The other side is going to be 4y minus 3 divided by 2 plus y. Perfectly fine answer. It's an ugly problem, but it's doable because the steps never change. If you just follow the steps and your answer is going to pop out whatever it looks like. You know, it might be a nice little number like 25/13, or it might be some ugly mess like 4y minus 3 over 2 plus y. Nothing wrong with that. Perfectly fine answer. Another possibility. Where's my other possibility? There it is. Oops. For example, there's a problem with this one.
Is that first, the denominator, the first one?
Well,
Yeah, you wanna break it down?
this one's slightly different. Well, maybe over here too. Like over in this example, we had 4 minus x in the bottom. The problem is the variables in the bottom cause us a problem. Because we definitely don't want the bottom to equal 0. So in that one, x cannot equal 4. In this one,
X cannot equal 3.
-3,
negative 3 or positive 3. I highly suggest if you see variables in the bottom, your first instinct should be, well, I definitely do not want x equal to negative 3 or positive 3. And the reason you might want to do that at the beginning is that after you do all the work and you come up with x equals 3, you can't leave it. Because x can't equal 3. Even though the equation might say x equals 3, it can't be. So then you get an answer that's called no solution. NS or circle with a line through it. But that only happens if x equals 3 or negative 3. All right. Now let's solve the equation. X squared minus 9 factors into
X plus 3, x minus 3.
x plus 3, x minus 3. Difference of perfect squares. And to get rid of the fractions, which is our first step,
You have to multiply everything by x.
multiply by those two. Okay. So if I multiply by those two, I'm going to multiply this one by x plus 3, x minus 3. Multiply this one by x plus 3, x minus 3. I'm just going to distribute it automatically. X plus 3, x minus 3. The nice thing about doing it to every single term is you can actually physically cross them out and see what's left instead of trying to do it mentally. It's just a neat little shortcut. So in the first term, what crosses out? Everything. What's left?
2.
That 2 up there. So 2 minus, what crosses out here?
The x plus 3.
The x plus 3's are going to cancel and you're left with.
X minus 3.
Don't forget the 1. And keep the x minus 3 in
Parentheses.
parentheses. So it's 1 times x minus 3 is equal to, what cancels out here?
X minus 3.
The x minus 3 and you're left with 5 and the quantity x plus 3. Best to leave things in parentheses if they started off that way. Alright, next step of course is get rid of the parentheses. So 2 minus x plus 3 equals 5x plus 15. That should come second nature to you. The next thing that should come second nature to you is combine like terms. So this is 5 minus x. 5 minus x is equal to 5x plus 15.
I have a question.
Go for it.
When it's like that, could you just divide the 5 now? No? I guess no. Never mind.
You're going to hurt me, aren't you?
I didn't.
Follow the steps. Don't just
Okay.
because everything looks like it's a multiple of 5, don't just go divide by 5.
Okay.
Because he doesn't have a multiple of 5.
That's right. You
If
gotta
this
do
had a
both
10,
sides.
If this was a 5, a 10, a 5, and a 15, sure, divide everything by 5, make things life easier. But I wouldn't jump to division until the very, very end.
Okay.
All right, next step.
Add X.
I would add x, move him over. So you're going to get 5 is equal to 6x plus 15.
And you subtract 15.
If you subtract 15 from both sides, you're going to get
Negative 10.
15.
negative 10.
Negative 10
I worry about your addition and subtraction. Equals
6x
6x.
divided by 6.
And I always show this step. Oh, I forgot to tell you why I always show that step.
And you
You're going to
subtract
get x is equal to
Negative 5
negative 5/30. So why do I always show division?
So
Because when I was solving equations a long time ago, you get down to something like 10x equals 5, and I would say x equals 2. That would be my big mistake. I would look at it and go, oh, yeah, 5 goes into, or to 10 2 times, and I would write x equals 2. But the answer really is
2/5.
1 half.
1/2.
Holy hump
Yeah.
ankles. And that is why I always show my division. So I can see that it's a small number over a big number, and the answer has to be a fraction. So I always show my division. It is my common mistake. So here's the thing. If your common mistake is dragging this x across the equation and making this 4x, show the adding x. Show it. It's not a big problem of showing your work because then I see what the heck you're doing. If your big problem is you're moving the numbers the wrong way, show your work and see that you're actually moving them the wrong way. So if you start making mistakes solving an equation and they start coming up the same types of mistakes, start showing your work and proving to yourself that you need to do it a little bit differently. So I always show the division because that's my common mistake. Does that make sense? If you make a mistake and you know it's common, show all your work and then hopefully that mistake will go away. Be really careful of signs. Plus to minus, minus to plus, changing signs as you cross the equation, all that fun stuff. All right. Done with that one. We'll need the book for the last part. This is 1-2. I'm just going to steal some problems from the book. I'm sorry, not 1-2, 1-3. On page 126. Way go back there. So 1-3. Anytime you see the word applications, the next thing that should go next to it is word problems.
Oh, child.
Word problems, they sound horrible. Oh, that's bad. So they're not that bad. They're not
Should
bad.
page 126.
Page 126. In our nice little Pulitzer pepper. Let's start off something easy.
No.
Something easy. Number 4. When a number is decreased by 30% of itself, the result is 28. What is the number?
Too much already.
That's it.
when a number
But it's not really a word problem. It's
X
wordy.
minus,
X minus 30.
Well, how do you find 30% of a number?
it's gonna be 0.30.
0.30.
So
Then you have to choose a number.
over 100.
Do we know the number?
No.
No, so we call it
X.
x. So your first step is to take 30% of some unknown number, which we'll call x. Now, how do you decrease a number by 30% of itself?
Subtract
You subtract it from?
30%.
No,
Or
1.3.
X.
from x.
I use X minus.
If you go to the store and something is 20% off, what do?
Subtract 20%.
Put it in
You
the
take
calculator.
20% of the cost, say a $100 item, and you take 20% of it, which would turn out to be $20. And then you take the $20 and you subtract it away from
100.
the original cost. So the original cost here is
Oh no.
x. Is x. Okay. So now we get x minus 0.30x.
It's equal to 20.
Now hold on. Variables are exactly the same. That means these are like terms. If these are like terms, that means they.
Combine.
How do they combine?
Negative 31.
What?
It's
Okay, let's go back to money. This is $1 times x. This is 30 cents times x. $1 minus 30 cents is
70x.
70 cents of x. Holy
Oh, I
humperdinkles.
got it, I got
Ready?
it, I got it.
Type it in your calculator. 1 minus
I got
0.3.
it. I got it.
Decimals.
I got it.
You all think you'd be really good at it because money is based on decimals. All right. So if I take 30% off of an object, you're paying 70% of the price. I always hated the way they phrase sales as 20% off. They really should say 70% of the price. It makes more sense that way. All right. So now we have our setup, and they say, well, this number has to be 28, right?
Mhm.
So 0.70 of x has to equal 28. How do you solve for x?
Divide by 0.70.
Stop having a headache. This is simplistic.
Divided
Divide both sides by
0.70.
0.70. And your answer is?
40.
What's really scary is you type that into your calculator. What's 28 divided by
I
7?
don't know.
It's 4. Move the decimal over. 40.
Why did you tell me I was wrong?
I didn't. I said, why are you using your
Oh,
calculator?
because I can't use my brain for simple stuff like that anymore. I'm addicted to the calculator.
How horrible. How horrible. All right, so that's number 4. Number 6. These simple problems, I don't know what it is about it. You learn these. By the way, you learn this stuff in 4th grade. 4th grade. But I'm just giving it an algebra twist.
Can you do like things over
I'm
up?
about to say, yeah, for real.
Yeah.
It's so much easier.
4th grade style, sure. 6. By the way, number 6 does not solve with is over of.
But that one could. So that's why you don't do all of them.
That one doesn't do is over of because then you have to
It's
convert
over
30% into 70, and if you don't do that, you're going to get it wrong every
Oh,
time.
okay.
So number 6 is going to be 0.8.
Yeah, number 6. When 80% of a number is added to the number, the result is 252. All right. So how do you find 80% of a number?
It's going to be
80x. You really don't need the 0, but it's fun.
plus 1x.
Plus 1x because you're adding it back to the original number, and this result is going to be
0.1.
well 252, but this is going to equal
1.8.
1.8x. Now, this 1.8x is going to equal
252.
252. How do I solve for x?
Divide.
Divide both sides by 1.8. And you get x is equal to
252 divided by 1.8 equals
140.
140.
140. Okay. Now, these two problems are extremely important to understand. This first one up here, anytime you see sale price, 30% off, 20% off, that's the setup for it. It's going to be a subtraction, which will give you some nice little decimal. This one down here is a tax is one of them. This works for tax. You get taxed 7%, so this would be 0.07. And to find out your total cost, you'd multiply by 1.07. It also becomes a percent increase. Percent increase. This is also known as percent decrease. So these two setups are common between these types of things, sales and tax. If you get a percent increase in your salary, like for here, an 80% increase in your salary, you started off at 140, an 80% increase would bring you to 252. So that would be an 80% increase in your salary, which would be awesome, wouldn't it? 80%. Woohoo! And then just think of all the taxes you have to pay on it. All right, let's make the problems a little more, horrid. Do not be afraid of word problems. The first thing you really should do is read the darn things. I have seen people, and this is scary, they see words on a piece of paper in math class, on a test, and they skip it. They don't even read it, they skip it. And sometimes the word problem is, what's 1 plus 1? I'm going to do that one of these days. Word problem, what's 1 plus 1? And they'll be like, oh, I don't know. Because it's a word. Oh, well. Let's try number, just to look at something.
More word problem.
Oh, well, I don't consider this one a word problem. If you look at it. Well, you don't have your
But
book.
look at
See, right there.
See, 18 is not a word problem. 18 says, well, here's y1. Here's y2. Here's y3.
Undefined.
It's fine. Yay! They give you these. Not in words, they write them down. This is called a formula problem. And then they give you some words. How horrible. The difference. What the heck does the difference mean? You're going to subtract. So someplace there's going to be a minus sign. The difference between 6 times y1. How do I write that?
6 times
6 times
1x.
y1.
Okay.
6 times y1. Why jump ahead? And 3 times y2. What am I going to do with these two?
Multiply.
Subtract.
Subtract them.
Oh,
The
yeah,
difference
the difference
between. I'm going to subtract them. Hey, they're words. Just follow the directions. I worry about you guys cooking.
But that's not
Period.
it, though.
Oh my God, the recipe says add 4 cups of sugar. Oh,
I would say 5.
I put 5.
I'm
All right, so the difference between 6 times y1 and 3 times y2, we got that down, is, as always, equals. The product of 7 and y3. What the heck does that mean, product?
7y1.
Multiply 7y3. Woohoo! So this is the words in symbolic form. Now, what should I replace y1 with?
Y.
1 over x. What should I replace y2 with? Well, y2. What should I replace y3 with? Well, with y3. Just do a substitution. But make sure when you do a substitution that you put it inside parentheses. So it's 6 times 1 over x minus 3 times 1 over, what should I do with that x squared minus x? Factor. How do I factor it?
Take the X out.
Pull the x out. I had the other class, they said x minus 1, x plus 1. I'm like, what? Kick out the x, what's left behind?
X minus 1.
X minus 1. All right, is equal to 7 times y3. 1 over x minus 1. All right, what should I do now to solve this equation? You do that common thing, which is multiply everything by
X times X minus 1.
x times x minus 1. Every single term gets multiplied by this. I like doing it to every single term so I can do that canceling out thing. You cross them out and see what's left over. When it hits this first term, what goes away?
The X.
The x's go away. So that's gone, and we're left with
6
6 and x minus 1. So 6 times x minus 1 minus, over here, what goes away? X minus 1 gets canceled, and you're left with 3. Equal, I put the minus sign down. Equals.
The 7x.
The x minus 1s are going to cancel, and you're left with
7x.
factor of 7 and a factor of x. Yay! So, no more words, and no more fractions.
Now we could do
And now it's real simplistic. Get rid of the parentheses. Combine like terms. Which variable should we move? The 6. We're getting negative 9 is equal to x. We're done. Except I don't like leaving things negative 9 equals x. I like saying x equals negative 9. Nothing wrong with it. It's just, if you get in the habit of putting the variable to the right, I'm sorry, to the left, it just makes things look nicer. It is easy. They're all easy.
once you
We
get
can
that word
solve
problem
it,
out the
solve
way.
it too. When we put them on a piece of paper, you know what I'm saying?
Make quiz.
I haven't seen any of your problems on a piece of paper because you haven't taken my test yet.
You don't be here.
I'm here all the time. You leaving now?
Yes, sir.
Do 1, 2, 1, 3.
Okay.
Enough problems. Number 30. More words. A horrible. A discount pass for a bridge costs $30 per month. The toll for the bridge is normally $5, but it is reduced to $3.50 for people who have purchased the discount pass. Blah, 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 blah. Determine the number of times in a month the bridge must be crossed so that the total monthly cost of both of these plans is exactly the same. Sounds wordy, doesn't it?
That's too much.
Now, before you go anywhere with a word problem, the first thing you should determine is what do you not know?
How
We
much
don't
the
know
bridge?
No, I know how much the bridge costs.
the total monthly cost with.
Now, something else that I don't know.
And discount pays
The number of times
The number of times
in a month the bridge must be crossed.
that you cross the bridge. So we're going to let x equal the number of crossings. You have to know what you don't know first. It's a weird way of thinking, but you really have to know what you don't know, and you have to give it a label. So that when you get done with all this algebra stuff, when you're at the end, you know what the heck that letter stands for. So here we're going to let x equal how many times did we cross the bridge. Now, in the word problem, there's also two pieces. What are the two pieces? No. You have something going on. There's a discount pass
and the regular price?
and a regular price. So a discount price and a regular price. So discount and regular. It's best to keep them separate. Deal with them individually and life becomes a little bit easier. So how much does it cost you per month for the discount pass? $30. How much per crossing with a discount pass does it cost you?
It says the total.
How much does it cost to cross a bridge if you have a discount pass? $350. So the numbers that are associated with discount are the 30 and the $350. Okay. Does the 30 ever change for the month? No, you pay it and then you're done with it. You don't pay it every time you cross the bridge. So 30 is what's considered constant. Is the $350 constant for the month?
No.
No, you pay it every time you cross. So if you cross the bridge 10 times, you're going to pay
Too much.
$35. How did I figure out $35?
Yeah, times 10.
Times it by 10. So it's going to be $350 times
Oh, times.
the number of times I cross the
X.
bridge. X. Now, that's how much it's going to cost me to cross the bridge for the month, because that's how many times I cross the bridge every single month. And then I always pay the 30. So what do I do with these two numbers? Add them together. So there's my discount cost for the month based on how many times I cross the bridge. All right, what about regular cost? Well, there is no $30, but there is $5 every time you cross the bridge, and you're going to cross the bridge how many times?
X.
Now, this is how much it costs for regular crossings. This is how much it costs for discount crossings, and I want to find out when they are,
Same.
which means equal. And there's your equation. Ta-da! Not hard. You just have to pull all the small pieces out. Okay, how do you solve? That's easy. Move this over, and you get 30 equals, 150. And then divide both sides by 150, and you get x equals 20. You don't trust me? You don't trust me. I wouldn't either, but it is 20.
Yes.
30 divided by 15 is 2, and move the decimal over 1. So what does x represent? 20 crossings. So what does this mean? This is also known as the break-even point. Whether you did the discount or you didn't, if you cross the bridge 20 times, it will cost you exactly the same. If you cross the bridge more than 20 times, which way would you lean? Discount. If you cross the bridge less than 20 times, regular. So this is, something simplistic. All right, one more. Actually, a bunch than one more, but let's just do another one. Number 38. Do you see what's happening here? The worst part of a word problem is setting it up. But once it's set up, they're usually much easier equations than if I just give you an equation. They're usually very simplistic. All right, how about the selling price of the calculator is $15. Might as well write that down. Sell $15. Okay. If the markup is 25%, 25% markup, what is the dealer's cost? What is the dealer's cost? What does it mean to be a 25% markup?
So they mark the price
That's the
of
original
Yeah,
price.
So we need to find
Like-
out what the
Like if you go to J.C. Penney's and you look at a shirt and it costs $50, it probably costs J.C. Penney's $10.
$10.
Probably cost them $10. So then they put it on sale, 50% off. and it's down to $25, but they only paid $10. So they're still making a huge profit on a sale priced shirt. So you're thinking, oh, it's saving all this money. Yeah. And even, I mean, any sale you ever see, except for like closeout sales, even those I think they're kind of.
They, when
If
they
you-
close out sales, they take it back to the retail price. They take it back.
They say they take it back to retail price. Same with cars. They'll say, "Oh, we're selling this to you. How much it costs us?" No, they're not, because then why would they sell it? There's no point. Plus, they have to pay. When they have a car on their lot, they're paying interest for that car. They're borrowing money to have that car on their lot. So they're not going to sell it to you for how much they paid for it, because they've already paid more than that for the car. So when you go into a store, it's marked up. The markup price is $15. So what don't I know here?
The original.
So we're going to let X equal original price. How much it cost the dealer. The dealer. Drug dealer. So if X is the original price and that price was marked up 25%, how do I do that? Well, you take 25% of the X, and then what?
Equals.
No. If a thing costs $100 for the dealer, and they took 25% of $100, that would be $25. Are they going to put it on the floor for $25? They're going to add it back to the original cost. So they're going to add it back to X, and this comes out to be X plus 0.25X equals
15.
1.25X. Where are you getting 15?
I don't know.
Oh, you're trying to set up the whole equation. Yeah, you could do that.
I need to slow down.
Okay. I just wanted to make sure I got these two together.
Gotcha.
So this is the markup price. Right here. That's the markup price. But the markup price, for our purposes, is equal to $15. Okay. How do I solve for X? Divide both sides by 1.25 and we get X equals 12 bucks. So every time they sell a calculator, they're making a profit of $3.
3.
Well, yeah, it costs them 12 bucks to buy it, and they're selling it for 15. So the difference between that will be profit.
So they're not making any money.
They make $3 a calculator.
I mean, that's nothing.
Yes, it is.
If you sell 100 calculators, that's $300. I mean,
How much is it gonna take to buy more though? Okay, like when I
$12 a calculator.
No, but see, when I saw my pocketbooks, I did something similar to this. I made sure that I got back. My profit one won't be $3 when I saw my pocketbooks, even if I paid
All right, buying
$5.
your pocketbook.
Even if I buy my pocketbooks for $5,
Right.
I'm gonna make at least. I'm gonna try to triple $5, and I did it every time. Cause if I bring you a pocketbook and I'm selling you this nice, pretty pocketbook for $20, and you buy it thinking you got a deal, then I just made all that profit.
And then another company comes by and says, "Oh, I could do it for less," and then your company has to go less. And then you get into profit margins.
You're right, but I saw.
How many people sell calculators? No, you can go here to the store, you can go to Office Depot, you can go to Best Buy, you can go to the grocery store, for God's sake. And everybody's going to want to sell them. And if they don't sell them, then they owe the company $12 for calculators, so then you want to bring your price down on your profit margin.
But you know.
But if you're in a niche, homemade purse, that's different. My dad.
Well, see, the thing that I used to do is I got my money back because I wouldn't just order my stuff online or do this. I would drive all the way to New York and pick out my pocketbook. So yes, I'm gonna make my big. I'm gonna
Give me my money.
because the gas. Because in the time, because I would go to New York on Thursday and be right back by Friday. Yeah.
You don't do it anymore, though.
If I had, once I get done with school, I plan on starting back.
You go back to it?
I love it. We go to New York for a day. Get up at 3 o'clock in the morning, drive to New York so we can be there by the time the stores open. And then, by the time everything's done,
You want
we leave.
to quadruple your money? Next time you run up there, bring a case of cigarettes with you.
Oh, we've done that.
Sell them up
Done
there.
that.
But then, of course,
Done that.
you could be
We gotta get,
put in jail for tax
yeah,
evasion.
it's illegal to do that. That's illegal.
He
No,
doesn't
who
care.
set up? No, you know.
It is illegal. 'Cause
Unless you're an Indian. All right, number 46.
Oh no.
Geometric. Try to get me out of these word problems. Geometric. The length of a rectangular pool is 6 meters less than twice the width. Ooh, how horrible. If the pool's perimeter is 126 meters, what are its dimensions? Whenever you're dealing with a geometric problem, draw a picture. They're talking about a rectangular pool. Here's your pool. It's all right. In-ground pool. There. So the length of a rectangular pool is 6 meters less than twice the width. You always go for the measurement that you know the least about. So which one do we know the least about?
We don't know the width.
The width. So we're going to call the width
X.
x. And we're going to base the length off of the width. Now the width says it is, I lost it already, 6 meters less than twice the width. So the first thing is twice the width would be 2x, and then 6 meters less means subtraction someplace. But is it 6 minus 2x or is it 2x minus 6?
2x minus 6.
It's going to be 2x minus 6 because it's 6 less than 2x. If you're 6 years less than your friend's age, then you are 6 years below your friend's age. So this becomes 2x minus 6. There is a certain phrase that keeps the order the same, but I always forget what it is. It's usually reversed, usually. All right, so the other thing I know about this is the perimeter of this rectangle. It's 126 meters. How do you find the perimeter of any object that is not a circle?
Yeah.
No. Of any object that is not a circle. Add up all the sides. There is no formula. 2L plus 2W, that works fine, but there's better ones. And here's the other problem. Later, we're going to get rid of sides or add sides. And 2L plus 2W is not going to work because it's technically not going to be a rectangle, even though it has a rectangular shape. So formulas are not the best way to go with perimeter. So if I add up all the sides, I'm going to get x plus x, and 2x plus 2x, and 2x plus 4x. So if I add up all my sides, I'm going to get a 6x. What else am I going to get? Minus 12. If you don't see that, put the labels in, combine like terms as you go around this object. X plus 2x plus x plus 2x, it'll give you 6x. And then negative 6 and negative 6 will give you negative 12. That perimeter has to equal 126. And once you get the setup, the rest of it is easy. Solve a simple equation. Add 12, divide by 6. Oops. 138. And then x is going to equal 23. Make sure on longer word problems that you read the question one more time to make sure you're answering the question. What's the question?
What are the dimensions?
What are the dimensions? So saying x equals 23 is meaningless because that's not a dimension of a rectangle. So you go back to the picture, well, x is equal to 23 meters. Make sure you get measurements in there. If it says inches, you better say inches and all that fun stuff. To find this side, I have to kind of plug it in. So you're going to get 2 times 23, which is 46. 46 minus 6 is 40. So this side is 40 meters. So the answer is 23 by 40 meters. Is the rectangular pool. We'll see. We'll see.
And it length first then with,
What's that?
would it be 40 by 22?
It doesn't matter which way you write it. Length, width, length. When you're dealing with a rectangle, notice you labeled this one the length and this one the width, right? Well, why can't this be the length and this be the width then? It doesn't matter. It's a rectangle, it doesn't matter. Why? Because it's commutative, either way you look at it. Perimeters are commutative because it's just addition, so you can flip the order of
Isn't
them.
always necessarily
And-
is bigger than what with the width.
Yeah, doesn't matter. Doesn't matter. Because this would be the length and this would be the width, or you can get rid of one of the words and say height. So this would be the length and the height, or the width and the height. It doesn't matter as long as you're talking about 2 dimensions. I don't know why people think the way they think.
Well,
Like for instance,
try to cut a piece of wood
I'm
like
about to
that.
say, yeah, that's how they label it in wood.
I know, but I'm not a wood labeler. Technically, it doesn't matter. What is that?
It ain't a square.
It's supposed to be a square. What? Is a square a rectangle?
Yeah.
Yes. Why? Because it has a length and a width, and it has 4 right angles. Yeah, rectangles are not necessarily a square. Not necessarily a square. Nah, that's just
Square had 4
geometry.
equal sides.
What's that?
I thought a square had 4 equal sides.
4 equal sides, 4 right angles.
But it has a length and a width.
It has a length and a width. They just happen to be exactly
Square.
the same.
I got you.
It's just geometry. Oh, let's try something simple. Number 66. I already did one similar to this, but 66 is all letters except for one number. A equals 1/2 H A plus B. And we want to solve for B. When there's multivariables, when they're asking you to solve for something, they have to tell you which variable you're going to solve for. Because you could actually solve for any of them. Doesn't matter which one. What formula is this?
I know.
Area of
Yeah.
Area of
Triangle, rectangle.
No, a cylinder.
a, how about a trapezoid?
Yeah.
Cylinder. Cylinder's going to have a pi in it because cylinders are made of circles.
I was thinking of a cone.
But it's still a circle. Still has a pi in it. Still has a pi in it.
So you said that's area of a rectangle?
Trapezoid.
Trapezoid.
You know, 2 sides are parallel. The other 2 sides are not necessarily parallel. You could also find the area of a rectangle with that, but I wouldn't suggest it. All right, so if I'm going to solve for B, B is buried inside the parentheses here. Follow the steps of solving a linear equation. What do you do first?
Get rid of the fraction.
Get rid of the fraction. It's going to cause you a headache if you don't. So how do I get rid of a half? Multiply both sides by 2. Now, question number 1. Does that 2 go any further than this half?
No.
No, it doesn't touch the H, it doesn't touch the A, it doesn't touch the B. Because you can only multiply 2 numbers together at once, not multiple. Alright, after you multiply both sides by 2, you get 2A. 2 big A is equal to H times
A plus B.
the quantity A plus B. So you get rid of fractions. Next step, get rid of parentheses. Distribute the H, and you get 2A is equal to AH plus BH.
Subtract the AH.
I'm not being difficult. All right, what are we trying to solve for?
B.
B, which is over here. So
Subtract AH.
the jump needs to go to the other side, because the B is pretty much all by itself on that side. So you're going to get 2A minus little AH is equal to BH.
Divide everything by H.
Divide by H because we're trying to solve for B. So we divide this by H, we divide that by H, and we get B by itself, because the H's will cancel. What's left on the other side is 2A minus AH all over H. Can you cancel the H's?
No.
No and yes. Depends on how you tackle it. If you do cancel the H over here, you better write 2A over H on the other side. But I highly suggest you just leave it.
Yeah.
Don't try to make fancy with that. The only way the H's would cancel is if both terms had it. Both terms on the top had it. That's fine though, leave it like this. Is that the only way to do it? No. My other class decided to distribute the 1/2 H. And they went through and distributed it. And eventually, when we got a little bit further down, they're like, oh, multiply by 2. I'm like, well, why didn't you do that in the beginning? But that's all right. Any good ones here? Oh, you better tackle this one because it is on my test. I don't know why they don't do it in the book, but I like this question. And we have just enough time for it.
So how many more problems are on the test?
100. I love word problems. Love them. You'll find that out soon enough. So guess what you're going to learn one way or the other?
Word problem.
How to do a word problem, because they're really not that hard. They're really not. People just treat them that way. You invested $8,500. Woohoo! We have money. Into 2 accounts.
Oh, I hate these companies.
Stop whining.
Is this a numbered problem in the book?
Nope. One earns. I made it up. One earns
God, I hate this.
5% APR, and the other, I think it's 8%. 8%. Okay. Simple interest. I'm not sure if I phrased that really well, but you get the idea. So you have this money, $8,500, and you're going to deposit it into two different accounts. Now, why would anybody want to do that? Why don't they just throw it at the 8% and be done with it? Nobody knows? Don't you want to make as much money as possible? I mean, that's the goal, right? You want to make as much money as possible. What's the danger of making as much money as possible?
What I can take from it.
You go into a different tax bracket. So if you're really, really close to the next tax bracket, you want to make as much money as you can, but you don't want to go over, because if you go over, you actually lose money.
Yep.
They'll tax it right out of underneath you. So this is a smart guy. He wants to make just enough money that he doesn't go into the next tax bracket. Okay. And the money he's going to make is $500. That's all he can earn in interest. Okay. So what does it mean to be simple interest? Do you know how to calculate simple interest? Anybody know the formula?
I forgot.
Starts with an I.
Interest
I
equals-
equals.
I equals
Is it PR?
PR
T.
T. Now T in this case is equal to 1, because it's only for 1 year. So technically the formula is for us, I equals PR. I equals PR. Interest equals principal times rate. Principal being how much money you put into each one of these accounts. So we have two accounts, a 5% account and an 8% account. And we're going to split our money into these two accounts. So how much money went into 5%? Do you know?
No.
So what do we call it? X. So I'm going to put X dollars in 5% account. X dollars out of my original $8,500. So how much money is left for 8%? Yes, you do.
X plus
Minus 5%.
$8,500
X.
less X, right? So this would be 8,500, but we already used up X dollars for the 5% account. This is where the subtraction is. So, how do I find the interest on X dollars when it's calculated at 5%? So you get 0.05 times X. That'll tell me how much interest I earned at 5%. How do I find the interest on 8%? 0.08 times 8,500 minus X. Okay. So this is the interest I earned at 5%. The amount of interest I earned at 5%. This is the amount of interest I earned at 8%. What has to be true about these two interests? Interests. Is there a plural for that? Interests. Interests. What has to be true about these two
You gotta
interests?
add up to 8,500.
No, not 8,500.
500.
500. So the amount of interest here plus the amount of interest at 8% better equal
500.
my total of interest of $500. And now that you have an equation, the rest of it is simple. Distribute. So we get 0.05x plus, what's 8% of 8,500? $680 minus
What, 88?
0.08x,
I
EX,
mean, point, yeah.
Equals
500. Yay! Now what?
Combine like terms.
Combine like terms, so 0.05x minus 0.08x
Minus 0.38.
minus 0.03x. This is still 680 is equal to 500. Now what?
Subtract the 680.
Subtract the 680 across and you get negative 0.03x is equal to
Negative 180.
negative 180. Okay, and then divide both sides by negative 0.03, negative 0.03. The first check for this problem that we've actually done it right. Negative divided by a negative is a positive. If you ended up with a negative answer over there, more than likely you got this subtraction backwards. Wrote it as x minus 8,500 rather than 8,500 minus x. So my final answer is x equals, well not my final answer, but my algebraic answer is, how much? $6,000. So, what is the answer to the question?
How much was in each account to start with?
So, how much did each account start?
It was
6,000 at what percent?
Mhm.
5%. What's that leave for 8%? 2,500. And that's the answer to the question. We put $6,000 at 5% and $2,500 at 8%. This is a very common problem. If you ever take chemistry, you do the same problem, except you do it with percentage of acid or a base. And then you do a little mixture. This is a mixture problem. And you find out how much has to be water and how much of it has to be pure acid to come up exactly with the right